أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله. I welcome you all again. Today we have a problem on centripetal acceleration. We know that if an object is moving along a circular path, and let's say this is the center of the circle, even if it is moving with constant uh, speed, let's say at this point you have its velocity in this direction, then at some other point you have its velocity in this direction here. This is v1 and this is v2. Now the change in this velocity, the change in v1 and v2 is directed towards the center of the circle, delta v, and due to this change in velocity you have an acceleration also directed towards the center of the circle. This acceleration, we call it centripetal acceleration. The reason for giving it the name centripetal is because it is directed towards the center of the circle, and it constitutes a force that is directed also towards the center of the circle, because if acceleration exists, force also exists. So F is equal to ma, where a is the centripetal acceleration and then F is the centripetal force, also directed towards the center of the circle. This is given as mv square over r, where this v square over r is the centripetal acceleration. Okay, having said that, let us now read the problem and solve it as usual. They said a record is playing at 45 revolutions per minute, meaning this is the angular frequency of the record. And then it changes from this value to this value. It means the frequency of revolutions changes from 45 to 33 whole number 1 upon 3 revolutions per minute. Find the ratio of the centripetal accelerations of um, a point on the rim of the record. Okay, when it was playing with this frequency 45 revolutions per minute, it has an acceleration attributed to, or let's say it has an acceleration due to this frequency. When it is moving now with 33 whole number 1 upon 3 revolutions per minute, the acceleration will have to change because the frequency change. So if I have these two acceleration, let's say the first acceleration due to this revolution is a1, the second one due to this is a2. The question is, what is the ratio a1 over a2? The ratio will be what? That is the question. So first of all, what is the formula for calculating this acceleration? Centripetal acceleration A is given by v square over r. V square over r. But since I am not given the linear velocity here, there is a relationship that says v is equal to r omega, where omega is the angular velocity. Okay, I can substitute omega r everywhere I have v here. So this means that I can say this is equal to r omega, okay, and that this is my v according to this formula, and then I divide it by r. I continue, this is equal to everything will have the square here, so r squared omega squared divided by r, and this is equal to r is going to cancel one of the r here, so I have 1r remaining, omega squared. This means that my acceleration is r omega squared, and from this formula you can see that if r is constant, because they say from a point a single point, since the point is 1, your r, which is the distance of that point from the center of the circle, will also not change. So it means what will make the centripetal acceleration to change is when the angular velocity changes, and angular velocity changes when the angular frequency changes. Okay, it means that we are going to have two equations with regard to these two angular frequency. The first one is that we will have A1 is equal to R omega 1 squared. Okay, we call this equation 1, and then the second one will be A2 is equal to R omega 2 squared, and we call this equation 2. Then how do we find this omega 1 and omega 2? Okay, the omega 1, remember we said omega in our previous class, we say omega is 2 pi f. Okay, so the f given, the frequency given are 2. You see that the first one is 45 revolutions per minute, and the second one is 30 whole number 1 upon 3 revolutions per minute. So it means this one, if I call this omega, if this is omega 1, this should be f1, and then this is equal to 2 pi multiplied by the frequency I am given, which is the first frequency, 45 revolutions per minute. I'm going to call this revolutions per minute. Okay, I'm going to leave this one. I will not change it to radian per second because they are going to cancel each other. The unit will cancel out, so just leave them like that. And then my omega 2 is equal to 2 pi f2, and f2 is the second frequency given, and this is 2 pi 1 upon 3 revolutions per minute. So this is 2 pi times 33 1 upon 3 revolution per minute. You see, so it means that uh, from equation 1, where I have A1 is equal to R omega 1 squared, it becomes A1 is equal to um, R open bracket my omega 1. Look at my omega 1, and I got this, so I will say 2 pi times 45 rpm close bracket squared. Okay, and then from equation 2, okay, equation 2, you see A2 equals R omega 2 squared. So this will now be A2 is equal to R. The R is constant, that is why we don't have to put 1 and 2 here. So this is 2 pi multiplied by 33 1 upon 3 rpm close bracket squared. Now if I want to get the ratio, I will divide equation 1 by 2. So I will, here is the thing, I will say equation 1 divided by equation 2. And how am I going to do that? I will take the left hand side of equation 1 is A1 divided by the left hand side of equation 2, which is A2, and equation 1 changes to this one. The right hand side is this of equation 1, so I will say R open bracket 2 pi times 45 and then rpm close bracket squared divided by, and then the right hand side of equation 2, which is this, so I have R into 2 pi times 33 1 upon 3 close bracket square rpm, and you can see the 2 unit cancel rpm, and then this one R cancel R. In fact, the 2 pi also cancel 2 pi with the square. So it means that at the end, what I'm going to have at the end will be, I will say this is equal to, I am left with 45 here divided by 33 whole number 1 upon 3, everything with the square, so I will change this one to improper fraction. So this is equal to 45 divided by 3 times 33, 99 plus 1 plus 1 will give me 100 upon 3. and everything must have this square. So this is equal to, I will now multiply by the reciprocal of this. So open bracket 45 times, then the reciprocal of 100 over 3 is 3 over 100, and then square. So here is how we are going to do. You just multiply 45 by 3, bring your calculator and do it. 45 by 3 will give you 135. So this is equal to 135 divided by 100 and everything raised to the power of 2. So here is how you do it. You open bracket first, open bracket, now press 135 and then divided by 100, then you close bracket. You see that this is what you have in the bracket. Then you can now press the square button. You press the square function and then you press equality sign. You see your result is 1.82 approximately, and this should not have unit. The reason is that you are dividing acceleration by acceleration. Acceleration is in meters per second square, this one meters per second square, and the two will have to cancel, so the ratio must not have unit. It's only 1.82. I hope this is clear to all of you, and thank you for watching. Assalamu alaikum wa rahmatullah.